Okay.
Good to
So the
go.
next session is with Kevin on the RDF, presenting like the RDF transform extension.
Sure, and I think this will go along with the previous presentation on the intro stuff. So I'll cover some of the same kind of things that you've seen before. Let's see, get my sharing up here. Share. I think I can do it all from here. Okay. So I don't know how many people are familiar with the RDF transform extension, but it's an extension on the OpenRefine site. You can find it. Let's see if I can go to OpenRefine real quick. This thing's in the way. Or it's on the site. Go to the download area, and there's a bunch of extensions that are shown. Obviously, you can get your download. At the bottom here, there's extensions, and all the extensions are listed here. RDF Transform is one of them listed here. It's actually a extension that was upgraded from a previous RDF extension, the RDF extension. I did it as a way of adding features that I found lacking in the original extension. I also was using GraphDB for a lot of RDF data, storage and such manipulation. And they had a similar feature in their system. So I was looking at some of the things that they were doing versus the RDF extension, and I kind of merged the two ideologies together to come up with what I was doing. I extended both of them in various ways, but mostly from the RDF extension with ideas from the GraphDB system they were using. So the actual extension lives in GitHub, of course, and has a bunch of information about, how to load it, install it, and such. Some people were using it and were rudely awakened to the fact that it used Java versions, and they were using earlier, Java 8, which was a standard install for many OSs, and didn't realize that when they were updating, they weren't updating past Java 8. So there was a big round of information about getting the proper Java version done, and I documented a lot of that. And I think then OpenRefine did a lot of work on their side too to get the extensions kind of in line with the Java documentation, and getting people clued into the fact that how to install the Java systems on their OSs. There's an interesting area in here, the wiki, which gives you some basic information about, what it's about as well. The releases are also listed here, how the version control is done. It shows all the features that are listed here, what you can use it for and such. There's even a batch mode process for using OpenRefine and using it like an API to just send it data and have it automate the process of converting data or whatever you want it to do. Inside the extension, I use a Lucene data store to store a lot of the RDF data elements, like the classes and the properties that you will use to do transformations and such. It just helps the user select ontologies or information from ontologies, classes, and properties that they need to use. And we'll look at what that looks like in the user interface. It's based on this idea of using a template, right? So basically what you're doing in the RDF extension is building a template. And then that template is used to do the transformation. So the templates look something like this. I actually got to update this because I've just changed all the namespaces and how they're done. But it uses like a subject mapping, a property mapping, and then object mappings. So subject, property, object, or SPO relationships. Everything in an RDF store is based on this triple idea. Really, there's a quad, but there's this triple ideology, right? So triple is basically a subject that's linked to an object through some sort of predicate or edge relationship. So it uses also a graph kind of analogy as well. Subject node linked through a predicate edge to an object node edge node relationship. All right. So having said that, in
Hey, Kevin, what's
OpenRefine,
the quad
yes.
part? What's the fourth one, the quad?
Okay, sorry. The quad is basically designating the triple belonging to a context of some type. That context
Context.
is realized as a graph. So you're basically saying this triple or these sets of triples belong to a graph. In essence, that's what the context generally means, right?
Okay.
It can be used within a graph to indicate, subgraphs and things of that nature as well. And then there's this whole idea of how you do, what do they call it? Reification, which simply means information about triples, right? So I can use a triple as a subject or a triple as an object itself. So you can say things about the triple or say things about sets of triples. And that context makes it an easy way of saying, here's a set of triples that belong to a particular context or graph. And then you can say something about the graph itself, right? And it applies to all the triples. Like, for instance, you could do provenance. These set of triples were created on a certain date, or these set of triples were created by a certain thing, or so on and so forth. Just a way of adding additional information to your graph of data. And they're all triples, really. So the context or the quad element is, and we'll see that when we express some of this information in the actual transforms. But it's just a way of capturing additional data or grouping data. All right, so in OpenRefine itself, of course, you would create a project and such. How would you go about doing that for OpenRefine is, well known. You just do what you do. But I have this project called FOC, and we'll get into what that means in a second. So I'm going to just kind of start at the end of the presentation and work kind of backwards. So I'm going to show you the results essentially, and then we'll go through the actual process. So essentially, you would load data in the OpenRefine RDF transform extension. This is the essential screen that you get for user interface. Hope everybody can see that okay. There's a little link here called See the Docs up here at the top. And what I'm going to do is basically just go to that. And in that, there's basically a website built into the application itself. So it basically tells you, about the user interface. Some of this is dated. I've got to update it a little bit. But the point, though, is that I try and keep it updated with like the news about the releases and such. That's down here. It's basically, it's already installed. So it's kind of cart before the horse, right? So it tells you how to install it, but it's already installed. Download it, get it set up and everything, where to download it from and such. But there's this tab here called Showcases. And there's this example in here called Flavors of Cacao, or FOC. FOC also is funny because it's related to a movie called Dead Men Don't Wear Plaid. If you know anything about Friends of Carlotta, you might want to look that up on the aside. But anyway, there's this site called Flavors of Cacao. And you can go to that database and look at the information there. We'll just go there real quick. So Flavors of Cacao basically have a database here. It's just shown as a table, essentially, of all these different pieces of information associated with chocolate, cocoa beans, and such. So someone went to a lot of work managing all this data and then publishing it. What's interesting, though, is that we can use this as an example, of course, to do some transformation information into RDF data. At the site, there's also this little piece of Python code that you can use to do a variety of downloads of data from websites and such. But this is a simple, beautiful soup related Python code that simply downloads the Flavors of Cacao database at this location here into a CSV. And then you would load it, of course, as you normally do. I do I do very little to get it into the OpenRefine data store. I just normalize any like blank spaces or anything like that into nulls. I think that's the minor kind of things I need to do. And then what we want to do is transform it into some sort of RDF store, which will look like, or file, which will look something like this, where we got prefixes. And then here's the first entry for the chocolate 0 entry, which we're calling it a chocolate entry. And there's a reference ID associated with it. You can see that from the table up here: reference, company, location, view, bean origin, and so forth. We'll do some nominal renaming in the transform process, like for review date and bean origin country and bean origin bar name, and so on. We'll break down the ingredients, and that's an interesting thing. The ingredients are stored as this kind of weird string, right? So basically it tells you how many ingredients with a dash, and then some short letter kind of ingredient list. And you can see that at the database itself. It tells you, here's the ingredients: B for bean, S for sugar, S asterisk for a sweetener other than sugar, cocoa butter, vanilla, various other ingredients. And then we have a new characteristic here called the memorable characteristics column, which could be broken down into separate kind of elements itself. And in general, there's no more than about 5 of those entries in any column. Of course, you could use OpenRefine to break these things down yourself, using OpenRefine directly to do some of this separation of information before it gets into the RDF transform extension. However, we're going to just do it basically straight up from the data here. Okay, so what we're going to do is look at how that transform is done. So this basically gives you an example of what we'd like to have, essentially. And then we're going to do some things like add some CASO relationships to Wikidata. I think that's going to be Wikidata or Wikipedia. And then those Wikipedia websites will be basically an extension to the data itself. But we can automate a lot of that. All right, so then there's some instructions down here, setting up the base IRI, setting up the IRI space for the data itself. We're basically saying this is the default graph that all the data will go into for an RDF store. Then we set up the various namespaces. We're essentially adding a chocolate prefix, a reference prefix, an ingredient prefix, and a wiki prefix for the Wikipedia data. All right, so let's take a look at what that extension looks like and how that's done. Here's the base IRI, and we just simply edit it, change it to whatever we want it to be, apply it, and it's done. That is essentially a namespace as well, but it's the base namespace. We can also add other namespaces. Some of the standard ones are already set up for a project. So RDF, RDFS, OWL, XSD, and vCard. Just to kind of go over what it looks like from scratch, I'm going to start a new session here and do an import just to get a project set up and show you what it looks like in that respect. Okay, so we'll create a project like we normally do. Let's see, where are we? CSV. Data. Let's see if I ignore anything. No, we already getting the column names and everything. Blank rows. I think we're all good there. Call this 2025 2. All right, so we get the data in, go into the transform. And it does some very basic analysis of the columns and such to get the essential kind of template set up, pulling it all from the project itself, from all the columns and such. So we have some sort of index, which is, of course, the initial indexed element for all the rows. It could be in record mode as well. It recognizes record mode. And then each one of the columns reference company manufacturers, so on and so forth. And if we just look at a preview of what the data looks like right off the bat, you can see it's going to do a transform, but it's pretty rough. It's using the column names converted into either properties or class names and such, and then just making the links to the data as strings of information. So it's pretty rough, but it does it, straight off the bat. It automatically selects a tri-G format for this because it's more readable than many of the other formats. Another popular one is Turtle. Tri-G is basically an extension of Turtle, if anybody knows about the RDF formats. It just adds the graph element, which is shown right here. All right, so what we're going to basically do is change all the names and such to a lot of the information here. So reference, we're going to add, these are the basic namespaces here. You can go right into manage. You can see that they're listed here. These are actual ontologies that exist on the web. And so it's pulling this information from ontology files that exist on the web directly and providing the Lucene data store that's underneath. The ability to give the user, prompt them for information, show them related kind of ontology properties and classes that they can use for their transforms. So if I pick on ref and say search for a property, I could type in RDF : and it shows all the RDF classes or properties actually here that you can use. Object direction type first. You see some of this is duplicated as well. I can use RDFS, get domain, subproperty, comment. C also will use this. I can use OWL. On property, on classes, just showing with all the interesting things you can do with OWL. Same as relationships. vCard. I use vCard to manage like contact information that's oftentimes embedded in a lot of data. So I'll transform it into vCard type data like organizations or individuals. And then their names will be, sub-elements of some sort of initial subject element. So I call it as an agent, or, has a nickname or email addresses, which are easily usable. Friend of a friend was also a very popular ontology for a while, which is basically a social networking kind of ontology that links individuals or organizations together, right? So this person knows another person kind of relationship. So knows is a highly used element in that for those social networks. Okay, so what we're going to do is going to add a few, and we'll go back to our example, and it says I need to change the base IRI to this Coco or Coca. So we did that here. And that one, this is the good one. Hit and apply it. And then it says in our example, we need to add some prefixes. So chalk is going to be this Coco space. So whenever you see these things in RDF, like HTTP :something, that often implies that these things really exist somewhere in the web. They don't. They can be completely imaginary. We could change this to a number of other types of namespaces, right? I could use a UUID string for these prefixes and such if I wanted to. So just to show you an example of what that looks like. We're going to add one, of course. That's the IRI we want to use. And we're going to call that chalk. Now like I said, this could be any kind of IRI formatted expression. In general, they use a lot of URI type expressions here, where it'll be some sort of protocol with a name associated with it. But I could just as easily do something like UID colon Coca colon, and that would be acceptable too. Okay, so it's added it. I can see in manage. There it is right there. So it's just a namespace I've added. I've told it all I want is a namespace. There's no ontology that really exists for this. So there's no refresh area where it either uses a file or a website to update itself. We'll add a couple others. So in the example, we have ref, which is going to be this friend of or friends of flavors of cacao chocolate reference. So we basically saying it's coming from the friends of not friends of the flavors of cacao area. All right, and oh, keep switching those things. Move this way over here. There we go. Okay, add another one. We're going to work on the ingredients and break them down, like I said. So the ingredients will have its own little namespace that we'll set up. And then Wikipedia will have its own little namespace. Okay, so we've just set up basically some namespaces we're going to use. For the reference, I'm going to change this name from the column name that it was to, I think it's just going to be chalk ref. And it doesn't exist. Let me make sure I'm getting that right. Yeah, it doesn't exist, so we're going to add it. And so I've just named it chalk ref now. So if we switch back and forth to preview, we can see now we've updated the data store a bit. Now we've got a chocolate info data store using the base name from the cocoa up on top. And we can see that my chocolate reference is now a predicate to the value for the reference. Again, all these are strings, and we're trying to turn strings into things, right? That's the whole idea behind RDF technology, is making them something usable. So instead of just a literal reference, we want to make that a some kind of subject or object element that we can reference and use in various places instead of just a string. So I'm going to turn that into an IRI. I can do that because these are fairly unique elements, right? The reference is unique. The company, manufacturer, names are unique to the companies themselves, and so on. So that's fairly doable kind of thing. You can see in the example of the system, I've changed some of these to R, which are references, versus L, which are just straight up string literals. All right, so the difference between a reference and a literal. The literals can only occur in the object column of a triple. References can occur either in the subject or the object area. And for all purposes, predicate is always a reference type thing as well, but they're a special one because edge element. So going back to our example, also in the user interface, you can see that there's three columns, obviously. There's a subject column, there's the predicate column, and then there's the object column. Now, the object column we can extend to be a subject of something else, a new triple. So we can add an object to it, and if it was a reference, then we can add a predicate and another object, and a predicate and another object. So this kind of tiers across the screen as a column with overlapping object elements as the new subject for another set of triples. And we'll see what that looks like in a little bit. But again, we want to make this into a reference that's actually a subject. So we're going to change it. Just to show you how I changed it in the actual project, we'll look at it here. Whenever I pick on the element that we're working with in either the subject or the object column, we'll see that we get this RDF node dialog. And we can pick various things and change them into various expressions and such. Generally, most things that starts up in the L column is going to be, as an L literal element, it's going to be text. And then we can change it to an IRI, or we can change it to other types of text, subtext elements, right? It could be a language element. It could be integer, double dates, booleans, any custom IRI you want to put in there, or a blank node. And we'll talk about blank nodes and what they look like in this system, because we are going to create a blank node. You can see that in the background here when we deal with the ingredients. All right, so in my expression system, I have a little Grell expression here. It's basically this 2 IRI string on the value. So I've added a couple of functions to the OpenRefine expression list. And one of them is 2 IRI string, and help. You can see that down here. Let's expand this a bit so that we can see it. So in the 2 lists of things, there's a 2 stripped literal. So it strips out information to make a literal. And it's really just doing some trimming and such like that automatically, replacing white space and such with normal spaces. And then there is a 2 IRI string, which it just takes a string and then it analyzes it for things that can't be part of the IRI and replace it with things that will substitute, like underscores for spaces and things of that nature. And then it produces basically a suitable IRI string that can be used in an RDF data store automatically for you. And so that's what I'm doing here, 2 IRI string value. Back in the working project, here we see we're using a ref column as text. I want to change it to an IRI. I want to tell it to use my chocolate or reference. Let's use the reference. because that's the one we actually want to use. And then we want to turn this thing into an actual IRI string. So when we do that, and there's some problem with some of this preview expression. Sometimes I have to hit enter on particularly long expressions for some reason. I have to hit enter before it'll actually update the data that it's getting. But aside from that, it creates the resolved, IRI that we're looking for in the expression. So that was our initial value, and now it's a IRI value. We go back to preview, and we can see our reference is now a ref number instead of just a string. All right, and then we continue doing this for other things like company manufacturer. Jump back over to the other project. Company manufacturer, I change into a vcard.org. The company's location is really a country. We look at the data. You see that's basically a country designation. And those are, that's a literal. The organization company I've turned into an actual resource or an IRI from the data in the company column. So if we look at it, again, just to IRI string value, IRI, using the chocolate prefix. Country name. And all I did, of course, is just go into each one of these, just type in what I needed for it. The review date, so is a date, and I want it to be a date instead of just a string of information. So we change it to an actual date. That's just a predicate, but the date itself uses this IRI expression. So the review date column, we're turning it into a date. But for some reason, and someone maybe can answer this, why it always does that, but I'm changing this. I'm checking if it's a non-blank value. Actually, I can go is not blank, I think. Yeah, it's non-blank. When I do this to date, this is my question to maybe some of you who might know. It's changing it to a string and using it, but I want to use this format here. And for whatever reason, it's never really doing it. It's always adding the time. And no matter what I do, I can change this to a known string value and it still converts it to this same format here. So what I've been doing is cutting it off, basically using cutting off this last part. So it's just a date. Anybody have any clue on that?
So OpenRefine doesn't have a data type. It only has date times.
Yeah, but this function to date.
Right, so it's turning it into so that's a misnomer. It's turning into a date time. So
Right, okay.
what you actually want is to use a format string with toString to convert the date into a string of the format that you want.
So this string doesn't actually apply.
That's parsing a string into a date. And then you're getting an implicit conversion back to a string on the outbound side. But it uses its default format for that.
I see. So we just, yeah, then you need to use a string format to change it to whatever you want. So this is always going to be like a UTI date, right?
Date time, correct, yeah.
Date time, yeah.
The online documentation is probably much better. We put some good effort into that versus this online help.
Right.
Example.
Right. So this is to convert it from some format to the date time, right? So this is not converting it to that that string, it's converting it from that string. Is that correct?
Yes, exactly.
Okay, good enough. So I need to do further processing on it, but you can take it as a date time format. That's fine. In the way it's set up here, I'm okay with that because I can just say date time and it will accept it then. My problem was I was trying to just use the date format like this, and when you import it into an RDF store, it complains at me that it's not in a proper date format because it has the time element associated with it. So, I mean, it accepts it, but because Fuzeki, the data store I'm using, is a little lax, but I can just use date time and it would be fine. All right, so anyway, we get the date time format set up. And then I change this to a chocolate bean origin country, which is the country of bean origin here column. The specific bean origin or bar name, I'm converting into a property here called chocolate bean origin bar name. These are just basically the literals for each one of these, so there's no real change except for the date. We've changed the date into an actual date formatted thing. So if I look at the preview, here's that date format, and it's being typed as a XML, schema date time. All the rest stay the same for the most part. What changes is when we work with ingredients. So ingredients is a little tricky, and also the characteristics. We're going to break those down into sub-elements. So in the project over here, we'll skip down to ingredients. We'll see we've just changed the predicate name to chalk ingredients. So you'll also notice I'm using, I don't know if you know this or not, but there's a kind of a unspoken rule, if you will, with RDF data. When you're using a namespace and such, or using an ontology, generally speaking, the predicates are always lower camel case related properties. So ingredients would be a lowercase I, and then classes of things would be upper camel case formatted things. You'll see that a lot in many of the ontologies. You don't have to follow that format, but in general, a lot of people you'll see do. A lot of ontologies are formatted that way. And then for the ingredients, of course, we're going to simply change this. We're going to extend this into a number of columns of information. And the way I'm doing it here is what I want to do is set up a blank node, because I'm going to break this into a grouping of elements. And I'm going to use a blank node as a container for those elements. So I'm saying, I'm using ingredients, but it's really a blank node. So nothing's going to be used here. Actually, the value is not even used. It just creates a blank node. But then you'll notice that I have a blank node element, and any of the resource or blank node elements, you'll see there's an add property. So now I can add a new property. And I can say, what kind of property I want from the system. I'm using this RDF LI just to indicate that there's a list of elements here. I'm also typing it as an RDF bag. All of this is in the example here exactly. So we're doing the transformation by adding types and adding properties and adding objects. And there's examples of what it looks like here. And then using the preview tab to look at things. So one of the elements I'm changing here is property to RDF LI. And I want to add a type. I want this to be an RDF bag. And a bag is just a container, right? It could be a sequence, or it could be a, something else, but we're using a bag to type that blank node as a container. And then RDF LI property, I need to link it to some object. And this is where it gets a bit confusing, because then you have to look at the data structure, of course. The data structure for this is that format 3 dash, and then a list of comma separated elements here. So I'm using a rather involved if statement to get all that information pulled out. At most, there can only be 7 elements, I think, in the ingredients. So it's a rather limited list, and there's probably a better way to do that, but I'll show you what I'm doing in the project. So here's my ingredients, and my big Corel expression ingredient is an IRI. So I'm going to break that down into again, transform it into an IRI, but I use this rather involved if statement to break up that information. So essentially what I'm doing is I'm saying, first of all, if it's not blank, this critical part here. If it's not blank, and that can just be non-blank. I transform it to that first element to a number. So I'm doing a smart split function, slicing off the first 3 characters and finding that that dash, and then I'm using the first array element from it to transform that into a number. I'm checking to see if the number is greater than 0. Most of them are 3 or more. We look at that background data there. So this is just looking at the first element, but it's checking to see if it's greater than 0. And if it is, then it's going to do that to IRI string. And it's using this interesting function called width. It's doing a trim on this value data, starting at the 3rd position, smart splitting it again, and then getting the first element, which is going to be the B or whatever it happens to be in that string. And then it's storing that information into some variable that I can use and test against. And then I got this elaborate if-then statement, if statement to break it down. So if it's a B, I want beans. If it's S, I want sugar. If it's S with an asterisk, I want non-sugar sweetener, and so on. And if it doesn't find any of those things, it just returns a null. And of course, if it doesn't find this as a number that's, or the number element is greater than 0, then it returns a null. And if it's not blank, if it's blank, then it returns a null. So basically that does that for 1 element, right? So what you'll see is that I've just basically copy and pasted this expression into the following sets of ingredients, and just increase this value and this value. So I'm saying if it's greater than 1, then use the first element. If it's greater than 2, then use the second element. If it's greater than 3, use the third element. And so it's a rather involved way to get the information transformed, but it's effective. So you say this says ingredients beans in this syntax here. Let's see if I can resize this. Okay. So you'll see the next one is again just checking if it's greater than 1 and then using the first element. Same thing. And it does that over and over again for all 7 of the entries that's possible in that list. So the bag element 1, 2, 3, 4, 5, 6, or 0 to 6, actually, so 7. And then on top of that, I'm saying that ingredient is typed as a chocolate ingredient. And then I'm adding a label to that ingredient saying it's a string. And you'll see that the string expression looks very similar to the ingredient expression. So the ingredient label expression looks very similar by using these strings, but the strings are slightly different, I think. They may be the same. I'm converting it to I'm just not converting this to an IRI now. I'm leaving it as a regular string. And then one other element that we're doing with the ingredient is the C also. And I'm converting it to that same kind of string, same kind of Grell expression. And I will be using a IRI, but you notice that I'm converting it to cocoa underscore bean and sugar substitute. Well, where did I get these things from? Instead of, non-sugar sweetener, I'm using sugar underscore substitute. Well, that's because this is coming from Wikipedia. And if we look up sugar or sugar substitute, just go do that. Oop. Let's see. Yeah, look. Sugar substitute. That's the website, right? So I'm using this as a namespace. And then this, of course, is the actual part of the website I'm linking to get that sweetener. And the same is true for the other elements as well. So cocoa butter, vanilla, lecithin, or however you pronounce lecithin, and salt. So what that looks like when we're all said and done with that process is those things are now broken out into individual components. Labels, see also elements in the preview. We'll see here's an ingredient. It's a bag, a list of elements, and you'll notice it uses this funky kind of a format for it. We broke each one out as an individual element, but it when it's doing the analysis of the actual streaming data format, it puts it in a comma format. So cocoa butter, comma, sugar, comma, beans are all list elements of that bag. But then you'll also see in another location the actual triple itself for this cocoa butter thing. Let's see if we can find one here. Chocolate, chocolate, chocolate. Here's an ingredient. Okay, ingredient, cocoa butter has a type of ingredient, and its a label is cocoa butter, just like we told it to. And then the C also, wiki cocoa butter. So we got that ingredient here for the C also by telling it, use the prefix wiki from the ingredient list elements. IRI, we're going to convert it to an IRI. And it's already normally in the IRI format because I use the string directly that represents the IRI as a URL, actually. And then the expression that gets me that data. Okay, so that's a breakdown of that. In a very similar way, we broke down the characteristics. So subject, predicate, characteristics. I did a blank node, has a bag type. Again, these are RDF LIs to do the list, the bag. And the bag contains the literal elements for each one of those characteristics. At most, there's 5 of them. There is an interesting problem with that. It contains the word and sometimes in the list. And so I'm doing a smart split on and to get that converted into a comma, which is what I really want it to look like. And I do that there. So if and has a length that, there's 2 elements, one before the and after the and, then my length of my array is going to be 2. And then I break it out into 1 and 0 and 1 with a comma between the 2. So it's in the normalized format. Otherwise, I just take the first element because there's only a list of commas. And then I treat that as a list and I break the list up and I get my elements out from that. So here we can see cocoa is the first element here. Since I'm using element 0. Let's do this third one here. So you can see it's done the same way, except I'm using element 2 in the list. So that should be full body, which it is. All right, so I'm just breaking them up into individual elements there. And then to end the demonstration, essentially, once I've got this transform done and I've done my preview and I'm happy with everything, I will use this and save it, of course, or whatever you're going to do, okay with it. You go to exports and you do an RDF transform export. And you export it as TriG, or I'm using TriGs because I'm doing it as a graph, or Turtle, or RDF XML, or whatever format you want. Stream formats are available too. Anything in the general library. And then once you get that format, you can load it into your favorite data store. I'm using Fuzeki in this case. And just to show you what that looks like, I've loaded it into a graph called Cocoa Info, like we saw. There's 5,000 some odd triples in the data store when it's all said and done. I can't edit it directly here because there's too many triples, but I can do queries on it. And I do. There's a number of triple processes I use here to do queries. Anybody familiar with Sparkle and how to do Sparkle queries? Nobody?
I think it's hard to put someone on the spot writing sparkles in front of everyone.
Yeah, indeed. It's a fairly simple query language. It's kind of SQL-ish, right? So I do a select on, I'm just saying, give me all the variables. Select all my variables from the chalk info graph, where in this case, I'm looking for all the organizations here. So I said it's a type, it's a thing, right? A vCard organization type. So whatever my subject is, it must be a organization type. And I get everything related to that organization. So when I run the query, I'm saying, here's the company name. It's a type of organization, obviously, but here's the type organization, showing it all right there. And the organizations don't have any other data associated with it, so I'm not getting any other P&O elements other than the organization one. However, I can extend these queries a bit. And I'll get through these queries pretty quick. I'm just copying and pasting from previous ones I've done. So I want to look at the Arret company, and I do it here by saying I want the vCard org chalk Arret, and the record that holds it, the subject that holds it, and then I want the bean's origin name from that company. So from that company, here are all the bean origin bar names that I get, and there's the list of names associated with that company. And then let's see, let's look at the ingredients. So surprisingly, there's ingredients all over the place, right, in the map of ingredients that we had. But there's only really a few select actual ingredients used for the entire data store. So I'm looking now for anything that is designated as a chocolate ingredient, and I want everything related to those ingredients. So here we got sugar. Oops. I thought it was a website. Sugar, it's a type, and it's a type of ingredient. And here's the label. And then here's the Wikipedia source for that. And I can actually click it because it's a website, an actual website. And it takes me to the thing. Of course, the presentation could be done in a variety of ways. I'm using the raw kind of Jenna Fuzeki format results to do that, but there are all the different ingredients, and that's all the ingredients there are. There's sugar, beans, cocoa butter, like then vanilla, salt, and non-sugar sweetener. And it's repeated a lot in the data store, in the data, But when you put it in an RDF data store, it's now normalized to a single set of entries, a single, condensed list of elements. So they're not repeated, but the links to the things are repeated. So for each bar or each entry, you'll have repeated links to these individual elements stored in the data store. And that basically ends the presentation. That's a snapshot, really quick way. But I invite you to go look at the internal website to it and look at this documentation. And then there are some spoilers in here. So I put a spoiler to the Flavor of Cacao template in here. And it's the actual template storing all the namespaces and the subject mapping, property mapping, object mapping. And you'll see in here, you start seeing the link expression code for the expressions. And here's the one, that very long one. Yeah. Show it's actually really there. For each one of those entries, repeated 7 times there. Any questions? I haven't been able to see the actual presentation because I'm doing the sharing.
It's mostly supporting links to your presentations being shared.
Okay. Good enough.
Looking at the time, wanted to maybe open the room, or I don't know if Kevin, if you have more in stores.
So there's alternative ways of actually doing this as well. There's a project called Sparkle Anything that lets you use data store, any kind of data structure that you have directly, and do queries directly on those elements to work with your data. Kind of an interesting project I've looked at. But this system allows you to basically structure that template and then use a batch process on a multitude of projects using the same template over and over again to extract that data. So an automated process of using OpenRefine.
Thank you, Kevin.
You're welcome.
Any question, comment? No, a lot of congratulations.
I had a question. Kevin, do you have
Yeah.
any recommendations for where you go to for community help with mapping, with ontology mapping?
Oh my gosh. The best ontology system, well, the most used, I should say. Let me just get to where I can answer that question effectively. There's an open source project that does ontology called, gosh, what's the darn thing called? Protege.
Right, Protege is a tool, but what
Yeah,
about in
Stanford.
communities?
Well, what I'm saying is the Protege group there, they do have kind of a community behind the scenes to support. Many people who do ontology work there communicate. There's a community area, and you can get answers on, how to construct your own ontologies and things like that. But most people are now moving towards this kind of Foundry model for ontologies. So for instance, the biomedical community has a Foundry for
OBO
biomedical.
Foundry.
Yeah.
Yeah.
Right. And so the government's doing the same thing. US government's doing a Foundry for DoD, Intel community kind of work.
Okay.
And various spaces are doing that. So you can look for a list of ontologies that they use, and they're all open source for the most part. You can get ontologies everywhere. You can just
Yeah, I put a few
search
links in the chat, but I was just curious if you were part of any of the, any of the communities, like you participate in any. So.
I do in the government space,
Okay.
but that's kind of membership is selective. You can imagine. Yeah. I have touched on the biomedical kind of industry a little bit, but not much. Of course, there's Wikidata. Wikidata is actually has a Sparkle endpoint.
Yeah. Certainly, there is some mapping that's done in Wikidata. In fact, I've contributed the mapping there for schema.org to Wikidata and a few other ontologies. So those are actually, like, the mapping is actually inside Wikidata. And there's a couple of Sparkle queries that you can do to extract that mapping and into CSV, TSV formats or whatever.
And DBpedia is also I guess
knowledge base.
It's a competitor to it as well, right? It's still doing Wikidata or Wikipedia scraping for all that. But the linked open data, I don't know if you've seen the linked open data sites or not.
Yes. Yep. That was a part of the community.
I'll put a link. They have the whole map. You can search that for data as well, and I think a lot of people have done that. There's a wiki site. I'll put that in there as well. There's them. Yeah, you can drill down into that space to do any searches for data communities you want.
Thank you. I'm going to stop the recording for that session so we can move on to the next and last session for today.